In this episode, we focus on a part of AI assurance that is easy to underestimate because it sounds like ordinary security hygiene, yet it directly determines whether an organization can honestly claim its AI systems are controlled. Access control is the discipline of deciding who can see, change, or execute critical assets, and then proving those decisions are enforced consistently. When the assets involve model artifacts, training and deployment pipelines, and configuration repositories, access control becomes a high-impact safety control because unauthorized or careless changes can shift outcomes for real people without anyone noticing in time. For brand new learners, it helps to imagine a school's grading system, because if too many people can edit grades or change the rules for calculating scores, then the system cannot be trusted even if it usually works. An AI system is similar because the model artifact can be swapped, the pipeline can be altered, or the configuration can be tweaked, and each of those actions can change decisions while leaving the surface-level system looking normal. Auditing access to these assets means verifying that the organization has restricted who can touch the levers that shape outcomes, that every touch is logged, and that access is granted for a reason rather than by default. Task 14 expects you to evaluate control, and access is one of the most direct ways to measure whether control is real. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. To begin, it is important to define what these assets are in plain language, because beginners sometimes treat everything technical as one big category. A model artifact is the stored result of training, such as a file or package that embodies learned patterns and can be loaded to make predictions. A pipeline is the set of automated steps that trains a model, validates it, packages it, and moves it toward production use, often with data processing steps along the way. A configuration repository is where the settings live that determine which model is used, which data sources are read, what thresholds are applied, and what fallback behavior happens when something is missing. Each asset matters because each asset can change behavior without a dramatic rewrite of the system, which is why these are prime targets for mistakes and for misuse. Auditing access means checking not only whether the organization has a password somewhere, but whether access is designed around risk, enforced through consistent controls, and supported by clear accountability. The reason this matters in AI is that the risk is not just data theft. It is decision manipulation, where the system keeps running but produces altered outcomes. For a beginner, the key idea is that control over who can change these assets is control over who can change reality for users. A helpful way to think about access is to separate reading from writing, because the risks are different and the controls should reflect that difference. Read access can expose sensitive information, such as proprietary model behavior, learned patterns that may reflect training data, or configuration details that reveal how the system operates. Write access is more dangerous in many cases because it allows changes that can alter decisions, degrade safety, or hide accountability. An auditor will examine whether read access is limited to those who genuinely need it and whether sensitive artifacts are protected from broad sharing. They will also scrutinize write access even more tightly, because write access is essentially the power to modify system behavior. Beginners often assume that if someone is part of a technical team, they should have broad access, but that assumption leads to accidental changes, unclear accountability, and increased insider risk. Strong access design follows the idea of least privilege, meaning people get only the access required for their role and only for as long as it is needed. When you audit access, you are checking whether the organization is actually practicing least privilege rather than simply claiming it. Model artifacts deserve special attention because they are both powerful and easy to misuse if access is loose. If someone can replace a model artifact, they can effectively replace the decision-making brain of the system, sometimes without changing a single line of code. Even well-intentioned shortcuts are risky here, such as copying a model file directly into a production location or reusing an old model because it seems familiar. Auditors look for controlled storage, such as a trusted model registry, and for strong rules about who can publish, promote, or retire a model artifact. They also look for integrity controls, meaning the organization can verify that the artifact retrieved is the artifact that was approved, not a modified or swapped version. Beginners should understand that a model artifact is not just another file, because it is an operational instrument that can shape decisions at scale. A good audit will ask where artifacts are stored, how versions are tracked, and whether access logs can show who downloaded, uploaded, or promoted a model. If those answers are vague, the organization may be operating on trust rather than control, which is exactly what Task 14 is designed to reveal. Pipelines are equally important because they are the machinery that turns data into models and models into deployed capability. If an attacker or a careless insider can modify a pipeline, they can subtly change how data is processed, which features are used, or which tests are run, and those changes can produce models that look normal but behave differently. Even small changes, like skipping a validation step or altering a filtering rule, can cause a model to learn distorted patterns or to pass checks it should fail. Auditors therefore treat pipelines as critical infrastructure, and they expect strong access controls around who can change pipeline definitions, who can run jobs, and who can approve outputs for promotion. For beginners, it helps to imagine an assembly line where someone can quietly remove the quality inspection station because products keep flowing, but defects increase. A pipeline without protected access is like that assembly line, because the system continues to deliver models even when safety steps have been altered. Auditing pipelines includes checking whether changes require review, whether execution is limited to authorized identities, and whether logs show a complete history of runs and modifications. The goal is to confirm that the pipeline is not a hidden backdoor into production behavior. Configuration repositories are the third critical asset category, and they often create the most surprising failures because configuration changes can be quick, frequent, and hard to notice when the organization lacks discipline. Configuration can control which model version is active, what threshold converts a score into an action, and what data source is used, meaning configuration is effectively the steering wheel for decision outcomes. If too many people can edit configuration, then the system's behavior can shift without the rigor of a formal release, and that is a classic recipe for drift, inconsistency, and blame when things go wrong. Auditors look for version control, review requirements, and controlled deployment processes for configuration changes, because those practices create traceability and accountability. They also look for whether configuration is separated by environment, so testing settings cannot leak into production and production settings cannot be casually modified. For beginners, configuration is like a set of rules for how a game is played, and if anyone can change the rules mid-game, the results become meaningless. Auditing access to configuration repositories is therefore about ensuring the rules are protected, changes are intentional, and the organization can prove what rules were in effect at a given time. Access control is not only about preventing deliberate misuse, because in most organizations, accidental harm is more common than malicious action. People make mistakes, especially under deadline pressure, and broad access makes those mistakes more likely and more damaging. Auditors therefore evaluate whether the organization has guardrails that prevent simple errors from becoming production incidents, such as requiring peer review for changes, using separate identities for automated systems, and limiting direct edits. They also check whether the organization avoids shared accounts, because shared accounts destroy accountability by making it impossible to attribute actions to a specific person. Beginners should see that accountability is not about punishment. It is about learning and improvement, because if you do not know who changed something, you cannot understand why it changed or how to prevent recurrence. Another common weakness is outdated access, where people who changed roles or left the organization still retain access to sensitive repositories. Auditors look for periodic access reviews and offboarding procedures that remove access promptly, because lingering access is a silent risk. In AI systems, silent risks are especially dangerous because outcomes can be influenced without immediate alarms. Logging and monitoring of access are as important as restricting access, because restriction without visibility can fail quietly. An auditor will ask whether the organization logs access to model artifacts, pipeline changes, and configuration updates, and whether those logs are protected from tampering. They will also ask whether logs are reviewed, either through automated alerts or periodic analysis, because logs that no one reads do not provide real control. For beginners, think of a security camera that records, but no one ever checks. It might help after a disaster, but it does not prevent the disaster. Strong access auditing includes alerting for unusual patterns, such as a model artifact being downloaded at an odd time, a pipeline being modified outside normal change windows, or configuration changes being pushed repeatedly without review. Auditors also look for correlation, meaning the organization can connect an outcome shift to an access event, like a threshold change, because that is how incidents are investigated efficiently. The combination of controlled access and strong logging creates a chain of evidence that supports reproducibility and accountability. Task 14 is about proving control, and evidence is how control is proven. A critical concept in access auditing is the difference between human access and machine access, because automated systems need permissions too, and those permissions can become dangerously broad if not managed carefully. Pipelines often run as service identities, and those identities may have the power to read data, write artifacts, and deploy configuration changes. Auditors examine whether machine identities are narrowly scoped, rotated appropriately, and monitored, because if a machine identity is compromised, it can provide an attacker with a fast path to altering the entire AI lifecycle. Beginners should understand that a machine identity is still an identity, and it should be treated with the same seriousness as a person's account, sometimes more. Another common risk is using a single machine identity for many pipelines, which creates a single point of failure and makes it harder to trace which process performed an action. Auditors prefer separation, where each pipeline or component has its own identity and permissions, because separation improves both security and accountability. Strong access control also includes preventing machine identities from being used interactively by humans, because that blurs lines and invites misuse. Evaluating these controls is part of auditing whether the organization can trust its own automation. Access auditing must also consider how the organization handles emergencies, because emergencies are the moments when controls are most tempted to break. If a model is causing harm, teams may need to act quickly, but quick action must still be accountable, because emergency changes can introduce new risk. Auditors look for an emergency access pathway that allows fast action while still recording who acted, what was changed, and why. They also look for post-emergency review, where temporary access expansions are removed and actions are validated through the normal process after stability returns. Beginners should understand that emergency access is not a free pass. It is a controlled exception that must be justified and cleaned up. A mature organization can move fast without leaving permanent holes in access control. In AI systems, a permanent hole can mean a configuration repository that remains editable by too many people or a pipeline that remains bypassable, which can cause long-term governance failure. Auditing emergency access is therefore part of auditing whether controls are resilient under stress. Another beginner misunderstanding is to assume that access control is only a security concern, when it is equally a quality and fairness concern. If someone can change data pre-processing rules, they can unintentionally introduce bias by excluding certain data patterns or by changing how categories are mapped. If someone can change thresholds, they can shift who gets escalated, who gets denied, or who receives special attention, which can affect fairness and user experience. Auditors therefore treat access to these assets as access to decision outcomes, not merely access to files. This is why access reviews should include governance perspectives, such as whether a person's role justifies the ability to alter high-impact settings. Beginners can think of this as giving someone the ability to rewrite school discipline rules. Even if they mean well, the ability itself must be carefully controlled because it affects people. Access control supports fairness by preventing unreviewed changes that could harm certain groups. It supports safety by preventing unreviewed changes that could produce unsafe outputs. In other words, access control is a governance control, not just a cybersecurity control. To make this real, imagine an organization that sees a sudden change in how many cases are being flagged by an AI system. Without strong access auditing, the team might suspect data drift, model degradation, or user behavior changes, and they might spend days investigating. With strong access auditing, The organization can quickly check whether a configuration change was made, whether a pipeline was modified, or whether a different model artifact was promoted, and who performed that action. If logs show a threshold change by an authorized person with an approved change record, the investigation becomes focused on whether the change was justified and whether it had unintended effects. If logs show an unexpected model promotion or an unreviewed pipeline modification, the investigation becomes a security and governance incident. Beginners should see that access auditing reduces time to truth because it helps the organization distinguish between external change in the world and internal change in the system. It also supports corrective action because knowing who changed what allows the organization to fix the process and prevent recurrence. This is why access auditing is not a bureaucratic add-on, but a practical capability that protects systems and people. When you step back, auditing access to model artifacts, pipelines, and configuration repositories is about verifying that the organization can prevent unauthorized change, detect suspicious activity, and prove accountability when outcomes shift. The evaluator looks for least privilege access design, separation between read and write permissions, and strong controls over who can promote models, modify pipelines, and change configuration. They examine whether machine identities are managed carefully, whether logs are complete and protected, and whether reviews and alerts turn logs into real oversight. They also assess how the organization handles emergencies, ensuring exceptions are controlled and cleaned up, and they consider the broader impact on fairness, safety, and quality, because access is access to outcomes. For brand new learners, the core takeaway is that an AI system is only as trustworthy as the controls that protect the assets that shape its behavior. If anyone can quietly change the model, the pipeline, or the configuration, then the organization cannot claim it governs AI responsibly. When access is tightly controlled and auditable, the organization can prove that its AI behavior is the product of deliberate decisions, not accidental drift or hidden tampering, which is exactly the kind of proof Task 14 expects.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.